Hey guys, today we are going to be talking about principal inverse values, and basically this is going to be when we found exact values back in Unit 1. We're just going backwards and we're finding the ones of the inverse, so we're finding the angle that makes that ratio true. So your essential question for tonight is, how do I find the principal inverse value using the restricted range of any trig function? So originally, when we would find a trig function, we would find sine of 30 equals 1/2. Cool, great. So if I was looking for the inverse of that ratio, I would say that that's 30 degrees. Because remember, when you're taking the inverse, you're just flipping your x and your y. So when I'm looking in here, the ratio that gives me this angle is 30 degrees. Now, the only problem with this is, if you remember our unit circle and our all students take calculus, you would see here that sine is positive at 30 degrees. I agree, but it also can be positive 1/2 over here, and with this reference angle of 30 degrees, which would actually give me that angle of 150, and that would give me the same answer. So we have lots of different values that we could have for these, because I can still use the coterminal angles to think about those two quadrants. So what we're looking for today is just that first value that you find. So positive will be in quadrant 1, negative we'll talk about in a little bit, but again, it's the first one within that range of your inverse values. Okay, so we're going to talk more about general to find all the answers in a little bit, but this right here, we're just finding one answer, so this one would be 30 degrees. So let's look at number 2. It's the inverse cosine of 1/2. So I'm thinking about the angle that would give me a cosine of 1/2. And the easiest thing we can do here is if we draw the triangle to figure out that particular ratio. So again, we have a positive value in here, so I'm going to draw in quadrant 1 my triangle. I'm going to put my theta as a reference angle, and then I'm going to use my SOHCAHTOA. So if you need to remind yourself, SOHCAHTOA, and again, your cosine is your adjacent over your hypotenuse. So my adjacent side is going to be 1, my hypotenuse is going to be 2. You can do Pythagorean theorem here and find 1 squared plus what squared gives me 2 squared. But we also know about our special 30, 60, 90 right triangles that this would be side of root 3, length of root 3. So at this point you think, well, which of these of my 30, 60, 90 triangle, which angle is going to be opposite the root 3? And that would be 60 degrees. Or if we want to be in radians, that would be pi over 3. And so my answer for this, again, if they're asking degrees, it would be 60 degrees. If they're asking radians, it would be pi over 3. So again, you're just asking yourself, which angle is going to give me this particular ratio? So let's do a couple more examples. So the first thing, when I look at something like number 3, the inverse sine of -1 over root 2. The negatives are where it gets a little bit tricky, because if you remember from Friday or Thursday night when you watched that video, that you have restricted ranges on your inverse trig functions. And so for sine, we go from -pi over 2 to pi over 2. And the other trig functions that follow that are going to be cosecant and tangent. So when I'm thinking about where do I draw my triangle, before when you had these things, you would be like, okay, well, all students take calculus. Well, you know over here that your sine is either negative over here in quadrant 3 or quadrant 4. But because over quadrant 3, that's not in my range, because if I think about what I would label these, this guy's pi over 2, this guy would be -pi over 2, so my range has to be in these two quadrants for this particular function. So I have to either be in quadrant 1 or quadrant 4. So when I draw this triangle, I'm going to go ahead and put my reference angle in, my theta. I know that sine is opposite over hypotenuse, so this would be -1. This side would be root 2. Okay, and then you can either do your Pythagorean theorem or recognize that this is a 45, 45, 90, because we have side lengths of 1 and then square root of 2. So then when you look here, my reference angle would be 45 degrees. But remember, we have to be within this restricted range. So my angle, if I went around and I found this angle, that would actually give me 315 degrees. So I can't have that. I need to make this within my range. And so what I can do here is I know going backwards from my x-axis, that would get me a negative 45 degree angle, or negative pi over 4. So you always have to check your restricted ranges here. Check the range in order to find that angle. So just kind of as an overview, if you have sine, cosecant, or tangent, and they give you a positive value to find the inverse trig value of, you're going to put your triangle in quadrant 1. If you have sine, cosecant, tangent, and they give you a negative value in here, you're going to put your angle in quadrant 4 and look for that reference angle, and it's always going to be the negative reference angle. Okay, so similarly, we're going to look at the other restricted range that we were given, and that one was in between 0 and pi, so your other trig functions will fall under there. So cosine, secant, and cotangent all fall within 0 to 1, or sorry, 0 to pi. So same deal here. If you have a positive angle, you're going to put it in quadrant 1. Okay, that one's pretty straightforward. But if you have a negative trig value in here, you're going to put it into quadrant 2, because if you think about your, let me draw a quick coordinate plane. If you think about this guy is 0, pi over 2, and then pi. So my inverse values fall up above the x-axis, and so I need to make mine up in quadrant 2, which makes sense because sine is positive up there, so cosine must be negative. So let's go ahead and try number 4. We're going to go ahead, since this one is a negative value, I'm going to put it into quadrant 2, put my theta in there, and then cosine is adjacent over hypotenuse. And I'm going to go ahead and use my Pythagorean theorem here to figure out what this last side is. So I would have that x squared, or whatever you want to call that, plus square root of negative 2 squared equals to 2 squared. That gets me x squared plus 2 equals 4. So I would know that x is equal to the square root of 2. So I just found that missing side length there. So I know this isn't one of the special right triangles that we've talked about necessarily, but if you notice here, both of these legs are the same length, which means that this is an isosceles right triangle, which means that we have a 45, 45, 90. So as long as your legs are the same length, you know that you could technically divide everything by the square root of 2, and you would get that answer. Okay, so we know then that this has a reference angle of 45 degrees. But remember, I'm in quadrant 2, so I need to figure out what this angle is, what I just drew in blue. And the easiest way to do that is to say, well, how far away am I from that? So I would take 180, which is your axis, and then I would subtract 45, which would get me that angle was 135 degrees. And if I wanted to do that in radians, remember that this would be pi over 4. And that this one, if I count it around, this is 0 pi, this would be 4 pi over 4 if I wrote it with a common denominator. So I would have 4 pi over 4, or pi minus pi over 4, and I would find that equivalent angle would be 3 pi over 4. So knowing your unit circle could be really useful now if you can remember all those reference angles. Okay, the last thing I have to talk with you about are these special values to find the inverse cosine, sine, tangent of 0 and negative 1 and 1. So back in the day, during exact value times, we had a couple of ways we could do this. You could use your coordinate plane and remember the axis and those points. So this would be at 1, 0. This guy would be at 0, 1, negative 1, 0, or 0, negative 1. And then to remember that your cosine is your x coordinate and your sine is your y coordinate. Okay, the other way that you might have learned or might have remembered this was when we drew this chart for ourselves. And remembering that this chart is going to be sine, cosine, tangent. This goes with your 0 degree, your 90 degree, or pi over 2, 180 degrees or pi, and then 270 degrees. So when you're looking in here, if I wanted to figure out what is the angle where cosine is 0, I go into my chart and I see that it's going to be 0 here at 90 degrees and at 270. And that makes sense because there's also two places on my coordinate that we have a cosine of 0, that we have an x value of 0. Remember, we have to fall within the range that we've been given. So for cosine, it has to be between 0 and pi, or 0 and 180. And so the only one that falls between 0 and 180 is going to be 90 degrees, or pi over 2. Okay, last but not, well, I guess I have two questions. The other guy, again, same process here. We look for sine. We look for sine of -1. That's down here at 270 degrees. But if you remember, we need this one to be between -90, or negative pi over 2, and positive pi over 2, or positive 90. 270 is definitely not in between that. But if I look at my angles here, 90, 180, 270, we know that a coterminal angle right here on my x-axis would just be going the other direction, -90 degrees. So I could write that as -90 degrees. Okay, finally, if we're looking for an inverse tan of 1, a lot of times people will look at this chart and go, well, I don't have any tans of 1. This must be something, I don't know, undefined. But really what's happening here, up on these guys, you couldn't really draw a triangle with this particular ratio in it, because adjacent side of 0 over 1 hypotenuse, like that doesn't make sense. But for this one, you really can, because remember, it's 1 over 1. So if I took this guy, since it's positive, I'll put it in quadrant 1, put my theta in there. I have my opposite is 1, my adjacent is 1. If I did the Pythagorean theorem or knew my angles, my 45, 45, 30, 60, 90 special right triangles, I would know that side's root 2, and then I can recognize that this is a 45, 45, 90 right triangle, and know that this reference angle would be 45 degrees, or pi over 4. Okay, that's all I've got for you. We are going to practice finding these principal inverse values for the next couple days in class. So I hope you have a great weekend.